Hey guys, so today I'm gonna have this small talk about the implementation of GraphQL with the authorization in our microservice architecture, and I would like to talk why and how we did this. So basically, a bit of history. I've joined the company Auto1 Group back in 2015, and that was exactly the year when we started to build the microservices there. And of course, most of the companies, startup companies, at that time were using something like fast and dirty solution with the PHP and MySQL monolith. And when we started to build microservices, we were using REST everywhere. So the clients were communicating with the REST with the backend, and backend microservices were communicating using REST between each other. And basically, come on. And basically, the typical schema looked like this. So the client was sending a request, which arrived to API Gatekeeper, and then it went either to aggregation or some usual microservice. And the authentication authorization was performed on the Gatekeeper. So basically, the client sent a JSON web token. API Gatekeeper checked if the web token is valid and if the client has permissions. And the permission system, the security check, was built using the endpoints and method levels. So from our point of view, this actually had several drawbacks. So first of all, in order to show one page, a client needs to execute several requests. So for example, you're showing an order, and you also want to show invoice, you also want to show some customer information, and all these objects could be in several microservices. The second one, which is obvious for RESTful world, is that the client does not control what it receives. So the client asks, give me an order, and actually it needs only order number to show the list of orders, but backend is returning everything. And the third one is this permission thing. So we are checking based on the object and on the operation, but not on the business requirement. So we wanted to build it flexible. And we started to look into how GraphQL could solve our issues with this. So I guess almost all of you or everybody knows, but I will still give a small little intro into the GraphQL. GraphQL is a language which allows clients to build flexible queries and define what they would like to receive in the response. So the two main operations which are used are query and mutation. So query to get the data, mutation to update, create. There is also subscription, but I skip it. The query here, it literally says, give me a user with ID which equals 5, and return in the response only the fields which I listed, like ID, email, groups, and in the groups, I want to see ID and name. And mutation, it's actually another operation type. There is also operation name, update user. So usually, we can use the operation type also in the query, and this is like a shortcut version without the query word. And this says that I would like to update user with this specific ID, and I would like to set email and phone number to the values which I will receive in the request. So when we were building or designing our GraphQL implementation, we actually start thinking how we can do this, and we found out that there are two ways to do it. So the first one is the simplest, probably, in terms of how we think. So we have a schema. We have GraphQL schema, which says there is a user, and there are two fields, ID and email. And then we still need to work with this in our Java service, and for that we need an object, a class, some pojo, which will represent this schema with the same ID and email fields. And this one is called schema-first approach, and it has several drawbacks. When we want to update something, I mean, we want to change our schema, we need to also keep our classes consistent. And we need to keep the types same, and it kind of can be error prone and harder to maintain. And the other one is the code-first approach. So we can generate schema based on our classes. So we have a user class, and then the schema is auto-generated. And basically, for sure, we have selected this code-first approach, which is simpler and easier to maintain. And yeah, if you're interested in the framework, we used Speaker for this. But yeah, there are several more, or you can build your own if you want. So the next thing about that was how to build authorization. So when we think about authorization and permission, we usually think about objects and fields. So we end up with some matrices of permissions saying that there are objects, user, and there are read-write permissions, or even if you talk about object create, read, update, delete permissions. And just imagine the business comes to you after that and says, okay, everything is fine, but I would like to be able to limit the user by the country access. So for example, if a user has access to Germany, he can only edit German users, and so on and so forth. And then we end up with something like this 3D matrix permission with the layers of the country. And then it can get even worse. For example, you've implemented this, and then business comes and say, oh, that's fine, but we would like to be able to also limit the permissions based on the department. And then I actually failed to display it because it would be 4D dimension, but yeah, you can imagine that would be a bit messy. So we were thinking a lot, grooming and trying to find an approach, and we decided to go with permissions based on the business operation. So for the same example, where we want to update the user, we can create a mutation, and the permission is quite simple. So mutation, update user, and that's actually what we store in the permission database. And when we go deeper to the country, we used a kind of URI look-like schema for this. So that's mutation, update user, and then after the query, like query params, there is country equals DE. So if the user has this permission, he can update only in the Germany. And same for departments, so we can extend this permission layer as much as we can and as we want. So next question, which we had to solve, is where we would like to put this authorization logic. So the first obvious approach would be keep it there where it was legacy in the gatekeeper level. Yeah, we can do this, and it actually has several disadvantages and advantages. So it's fail fast, meaning that the client sends the request, authorization is done in the API gatekeeper, and it immediately decides if the client has permissions or not, and then returning the request. And actually, thus it creates less load on our business services. But on the other hand, it creates more load on the gatekeeper, and gatekeeper will need to parse the body, because we know that if we originally were doing this on the endpoint level, now in the GraphQL world, we are sending this query mutation in the body. And actually, this means that we are leaking business logic to the gatekeeper, which we decided we don't want to do. The other one would be injecting the authorization on the business level, so into the microservices. This is good because microservice is responsible for its own domain, but then actually we have this user service which returns the user with all the set of permissions, and it creates more load on this user service because each and every microservice will be requesting the user. You can argue that we can send all the permissions in the JWT token, but then it will grow if you have hundreds of permissions, and probably we also don't really want to do that. Caching is also an option here, but then we get in the question of cache eviction. So yeah, more load, and authorization logic is spread all over the microservices. So let's imagine we have hundreds of microservices. We will be doing these checks and the same logic. It's a bit harder to maintain and keep. And the complex scenarios. So let's imagine we have an order, and when it goes to a specific state, like a ready state, we need also to create an invoice. And in this case, we will be doing the same business operation in two microservices. And the microservice which knows about the order should not know about the permissions of the finance microservice, which keeps invoices. So yeah, there are some advantages and disadvantages, and we decided to move forward and actually put it on the GraphQL level. So authorization logic here is in one place, and it actually creates less load on the user service, same as with the variant with the API gatekeeper. And yeah, complex scenarios, it's simple. It will handle them nicely. And there will be no unneeded call to our underlying microservices. But as a drawback, it will create a bit more load on the GraphQL layer. So the final schema for us looks like this. So the client is sending a request, which goes to the API gatekeeper, and then API gatekeeper still performs the authentication. So it checks if the token is valid, it's not expired, and things like that. Then it actually goes to GraphQL with the authorization check. So GraphQL calls the user service, get permissions, and it actually generates this permission which is needed to execute the operation. And after that, it's calling the persistent microservices. So let's zoom a bit into our GraphQL service. So yeah, there is a controller for sure with one endpoint because it's GraphQL, not a REST. And then the request goes to GraphQL engine. And we actually have two blocks there. One is pre-authorization block, and the other one is post-authorization. What do we use them for? So pre-authorization is for sure needed because we don't want to send a request like update or create to underlying microservices because they don't have permission, as we already discussed. And yeah, it can also check some simple queries, checking if the user has permission to execute this. But then why do we need post-authorization in this scenario? So let's imagine we are getting an order. We are getting it by ID. And at this point, when the business logic happens, we still don't know what's the country of the order. And if we are limiting the user by this country, we will need to first get this order. And then after that, check if the country matches the order. So that's what actually post-authorization is responsible for in our schema. And one more thing is the filters injection. Let me explain a bit. So let's imagine a situation that a client wants to get a list of orders. And our business just recently opened in one country, let's say Italy. There is a new operator who has access only to Italy. And yeah, the business is quite successful. There are hundreds of thousands of orders. And the client requests, give me first page, give me first 10 results. So what will this do? It will go to microservices and says, OK, give me first 10 results on the first page. In the post-authorization block, it will compare searching. There are no country, like each of them is from Germany or France, but no Italy. What should we do next? Basically, we will execute the same request again. Give me the second page, because we still need to return something to the front end. And basically, that would be iterating over and over again, and we can actually end up iterating over the whole database in this case, which we would like to avoid, because it will create some enormous load on the database level. That's why we have this filter injection. So with the filter injection, we actually inject in the request the filter, because we don't trust client for sure on the backend side, and we want to be sure that it will get only Italy orders. So we inject this filter that country should be Italy, and then when a request goes to microservices, we actually ask, OK, give us first page of 10 orders from the Italy. So that's why we have this filter injection on top. And yeah, let me show you some simple code example. So basically, GraphQL query, GraphQL arguments, these are existing annotations there, and we added on top the GraphQL secured annotation. So developer, the only thing developer needs to do is when he's writing his method, he needs to annotate it with the GraphQL secured, and that's already will execute the checks based on the permission. So we have this some more parameters on top. So access query parameter key, which means that we want to check the user country, and the post authorization target, which means that we want to use this check against that we want to use this post authorization filter and use it against the user projection. The code itself is quite simple in this case. It's like use the API client and get user by ID and return projection for it. So the main idea is about these security things. And yeah, tiny looking under the hood. In the speaker, there is a resolver interceptor, which we implemented, and we executed this around in walk. So basically, if there is GraphQL secured annotation, then we are doing these authorization checks. So for a developer, it's quite easy then to create an endpoints and operations. He just needs to keep in mind that the operation name is still there. It's needed for sure, and just annotate the classes. So to summarize, with all these things, we actually get the front-enders very happy, even more than back-enders, because they are now can define what they want to get in the response, and they are taking control of the data they request. Then the flexible authorization approach. So we are building the permissions, and we can build any level of the business required for the permissions. Actually, when we moved from our post approach, from our REST approach to use the GraphQL, we also noticed that our page loaded twice faster. This is mainly because of the client is not sending multiple requests to the underlying services. And in the backend, which is in one data center, the requests are much faster than from client to backend operations. So yeah, basically that's from my side. Do you have any questions, or would you like to discuss something about that? Yeah. Downsides for the GraphQL. Okay, basically, yes, you're introducing one more layer there for sure. You can end up, so here we were not building public API, right? So it was for our backend, for our back office, like an admin page. But if you're building public API, you need to be very careful with GraphQL, because you're allowing user to request let's say recursively, right? For example, you have a user and it has groups, and then each group has users, and so on and so forth. And you need to limit this, so you need to keep in mind this thing. Other than that, yeah, I haven't faced anything. Basically, still the same as usual REST approach. Yeah. So there are two options. First one, since we are building the permissions very business-oriented, we can create a separate request, separate query with separate names. So one user has a permission to execute query which will return everything, or one set of fields, and the other one will return only the other, limited. And the second, we also use the same annotation on the response. So we can put it on the field, on top of the field, and it will be checked and filtered out if the client doesn't have this access to this specific field. Yes, yes, that would be post-authorization. Any other questions? Okay. Thank you very much.